Fluids in the body. General properties of fluids. By Assistant Professor of Medical Physics, Dr. Al-Arif. General properties of fluids. Fluid includes liquid and gas. The molecules constituting a liquid are not bound together with sufficient force to maintain a definite shape, but the binding is sufficiently strong to maintain a definite volume. Liquid takes the shape of the vessel in which it is contained. In a gas, the molecules are not bound to each other strongly, therefore a gas has neither a definite shape nor volume. Liquid has general properties such as density, pressure, surface tension and viscosity. The determination of the density of certain physiological liquid is often an important screening tool in medical diagnosis. The density, ρ, of substance having uniform composition is defined as its mass, m, in kg divided by the volume, v, in cubic meter. The densities of most liquids and solids vary slightly with changes in temperature and pressure. The pressure, P, of the fluid is defined as the ratio of the force applied by the fluid, in Newton, to certain area, in square meter, of the fluid. The pressure in a liquid increases with depth because of the weight of the fluid above. Fluid pressure is often measured in millimeters of mercury, mHg or torr, where 1 torr is the pressure exerted by a column of mercury of 1 millimeter high. Another important property for liquids is the surface tension, T. It is well known that liquid molecules at the surface of a liquid exert extra attractive forces on each other. When a liquid is contained in a vessel, the surface molecules near the wall are attracted to the wall. This attractive force between the molecules and the wall is called adhesion forces. At the same time, however, these molecules are also subject to the attractive cohesive force exerted by other liquids surrounding molecules, which pulls the molecules in the opposite direction to the adhesion forces. Fluids have different ability to flow through vessels. This refers to the viscosity of the fluid, which is an internal friction forces between layers of the fluid. It's very difficult for layers of a viscous fluid to slide past one another. When non-viscous fluid flows through a pipe, the fluid layers slide past one another with no resistance. If the pipe has a uniform cross-section, each layer has the same velocity. In contrast, the layers of a viscous fluid have different velocities, as shown in figure. The force required to move the upper layers of the fluid is proportional to both the area, A, in contacts with the fluid and the speed, V, of the fluid as given by the force, F, equal to the ratio of the product of the velocity, V, by the area, A, divided by the distance between layers, D, multiplied by the coefficient of viscosity, eta. The units of viscosity is the dyne s per square centimeter, called the poise. The table shows the coefficient of viscosity for some fluids of interest. Fluids in the body. The behavior of fluid plays an important role in the body. The blood system is the main transport fluid system for fuel supply and disposal of body byproduct. It serves for distribution of food contents, from the digestive system, and of oxygen, from respiratory system, to the body cells, and it serves also as transport system for disposing the byproducts, like CO2, of the combustion process. The heart is the main component of the cardiovascular system. Each time the heat contract, it pumps about 75 to 80 milliliters of blood through the systematic and pulmonary cycle. About 84% of the blood is sent to systematic cycle and about 10% to the pulmonary cycle. The contraction of the heart chambers is triggered by electrical pulses that are applied simultaneously both to the left and to the right halves of the heart. First as the atria contract, force the blood into the ventricles, then the ventricles contract, forcing the blood out of the heart. Because of the pumping action of the heart, blood enters the arteries in pulses. Blood pressure is measured with a special type of manometer called a sphygmomanometer, see the figure. The maximum blood pressure at the peak of the pulse is called the systolic pressure. The lowest blood pressure between the pulses is called the diastolic pressure. In a young healthy individual, the systolic pressure is about 120 torr, mHg, and the diastolic pressure is about 80 torr.